Welcome back to online Savi video tutorial on hydrology and irrigation engineering. So today we are discussing the module 3, that is hydrograph part, and the previous class we have discussed the runoff part. So in this class we are going to see what is the definition of hydrograph and its components, and what are the methods which are used to base flow separation. So coming to the definition of hydrograph, see, hydrograph is a graphical plot of a discharge of a natural stream or a river versus the time of occurrence at a particular point of stream. So if you have a river or stream, so whatever the discharge which is occurring through that stream, so we are going to plot that discharge versus time will give you a hydrograph. So in a simple terms, we can say a discharge through the river versus time is nothing but the hydrograph. And here, so this hydrograph shows the time distribution of a total runoff. So basically, so whatever the hydrograph which we are going to obtain, so that hydrograph will show the total runoff value. And here the discharge is expressed in terms of cumex or hectare meter per day, or in hectare meter per month. And so time is expressed, the x-axis is in time and y-axis is discharge, so that is expressed in terms of hours or days or month. And here, so as I've already told, discharge is plotted on y-axis and the corresponding time is plotted on x-axis. Okay, so this the hydrograph so is called as the storm hydrograph. So we have various names for this hydrograph, so it varies variously known as storm hydrograph, flood hydrograph, or a simply hydrograph. So why this hydrograph is necessary? See, the detailed analysis of flood hydrograph so is very important in case of the flood control and the flood forecasting, or if you want to establish some of the design flows for any of the hydraulic structures like dams, reservoirs, or canals. So for that particular purpose, this hydrograph, the concept is very important. And so basically the hydrographs are generated from runoff, so which is occurring due to the precipitation, so that is either from a single storm or a series of a storm. So that is called a storm hydrograph. So whatever the hydrograph, so which represents the runoff due to the precipitation which results from a single storm or a series of storm is said to be a storm hydrograph. And so hydrograph which is resulting from a single height storm, that is nothing but isolated storm, is nothing but a single storm, so we'll have only single peak. Okay, and also so if if the hydrograph is resulting from an n number of like series of storms, then you will be having a multiple storm. So a typical hydrograph will look like this. So you will be having discharge values on the y-axis, and on the x-axis you will be having a time, and the graph you're going to obtain like this. So this is a typical hydrograph. And the next topic is the components of hydrograph. So what are the components of hydrograph? See, we have basically three components of hydrograph. One is the rising limb and the crest part and the recession limb. So basically whatever the components which you are going to explain, so that are taken from a single peak hydrograph. So the figure which I've showed in the previous slide. Okay, so from a single peaked hydrograph, so we have taken, which is results from a isolated storm. So we have various components, that is that there are three main components of the isolated storm, that is called the rising limb and the peak or a crest element, and after that the recession limb. So these are the three parts of hydrograph. So let us see one by one in detail what are these components. So the first, you can see the figure here, how the typical hydrograph will look like. You can see here y-axis represents discharge value, x-axis represents the time, and you can see the curve here. So this curve is called the hydrograph, which represents discharge versus time. And here you can see this particular part is called the rising limb. The first component, that is AB, is called the rising limb, and you can see here this particular part, that is PC, is called the crest part, and from C to D this is called the recession limb. So these are the three components of the hydrograph. So let us see what is rising limb, what is the crest part, and here the point of inflection is there, so that is also we'll see, and what is recession limb. So the first component is a rising limb, that is the left hand side part, that is AB. Okay. So the rising limb AB is the ascending portion of a hydrograph. See, this is the ascending portion of hydrograph, which is corresponding the increase of discharge due to the gradual formation of storage in the channel, so which is existing in the area and also over the watershed surface. So how this rising limb will form? So because of the accumulation of the storage, once the storage starts increasing, then obviously the discharge will start increasing. So once the discharge starts increasing, the curve will start rising like this. So that particular part is called the rising limb of a hydrograph. And here it is also known as the concentration curve. The rising limb is also known as the concentration limb. And so in the earlier periods of storm, there are initial losses as well as high infiltration losses. Hence, the discharge rises slowly. See, in this rising limb, what happens? The rise of a curve, okay, the rise of discharge is very slow, because what happens? So at the initial cases, like initially when precipitation occurs, okay, so there will be a initial losses, that is, infiltration losses will be there. So because of that, the rising in storage will occur very slowly at the initial stages because of the loss. And also, as the time increases, the loss will stop. Obviously, as the time increases, as the time of precipitation increases, then what happens? The losses will become less, and also the limb will rise faster. Okay, the storage is going to increases as the loss goes on decreases. And due to that, more and more discharge from the distant part reach the basin outlet. So as I have already mentioned, so because of the decrease of losses, what happens? So the storage or the discharge is going to increase. And point A is, you can see here from the figure, this is the point A, which is called the starting point. So while B is called the point of inflection. Okay, so the curve AB represents the rising limb. So what is that point of inflection means? So that is a point where the curve of the slope of the curve, the slope of this particular hydrograph will become steeper. Okay, that particular point is called the point of inflection. And also the shape of the rising limb is controlled basically by the characteristics of the basin and the duration, intensity, and uniformity of the limb. So these are the factors which affect the shape of this rising limb. Okay, so that is, one is the characteristics of the basin, duration of the rainfall, and what is the intensity of rainfall, and whether rainfall is uniformly distributed. So based on that factors, the shape will vary. So that is all about the rising limb. The second component is a peak or a crest segment, which is called PPC. So as you see in the figure, so the peak or crest segment includes the part of hydrograph. So from the point of inflection, that is from B on the rising limb, to the inflection point on C, which is on the recession limb. For example, so if you consider this is the curve. So here there was a point B and this was point A. So B, from the point of inflection on the rising limb and the point of inflection on the recession curve. So this particular part, so this is a P. So this segment is called the crest or a peak of the hydrograph. So this both B and C are the point of inflection. So B is a point of inflection on the rising curve and the C is a point of inflection on the recession limb. And the crest segment is one of the most important component of hydrograph because it indicates a peak flow rate. So because as this indicates the maximum flow rate, so this is very important because we are going to, whenever we are going to design a hydraulic structure or whenever you are going to do a flood hydrograph analysis, so we are going to take the maximum peak flow. And the peak represents the arrival of flow at the outlet from all parts of the basin. So this, whatever this peak represents, so the peak point represents the arrival of flow at the outlet from all the parts of the basin. Okay, so this represents so the flow of water from all the parts of basin. And the last component is the recession limb, which is called the CD. Okay, the recession limb extends from the point of inflection, that is from point C of the crest segment to the point D. Okay, so I think this particular part you can see this is a D in the graph, and this is a point C in the curve. Okay, so this from C to D, that is point of inflection to last crest segment D, is called the recession limb, and this is the point of commencement of natural groundwater flow. So this point D represents the commencement of groundwater flow, and the recession limb indicates the storage contribution from the surface storage, which includes both surface detention and the channel storage. So an interflow groundwater flow. Okay, so whatever this the recession limb indicates, so recession limb CD indicates the storage from various surfaces, like surface detention, interflow, groundwater flow. So all those included in this recession limb part. So that is the third component. And also, so since the depletion of this detention storage takes place after the cessation of rainfall, the shape of the recession curve depends only on the basin characteristics and is independent of a rainstorm characteristics. See what happens, whatever this detention storage is there, like C to D, this particular part represents the like the storage, detention storage, groundwater flow, interflow, which occurs below the ground surface. So hence this does not vary with respect to rain characteristics. It will vary only with respect to the basin characteristics. So that is one important part in the recession curve, and it can be considered as a rate of discharge resulting from a draining of process, like groundwater flow, interflow, all those are called the draining process. So whatever the curve which is results from the draining process, that is called the recession curve. So these are the three components of the hydrograph. So the next topic, you have the base flow separation. So basically, we have three methods to separate a base flow from the total runoff. So the very first method is the simple procedure, like consists of drawing a straight line. So from the point of rise to an arbitrary point on the lower portion of the falling limb on the hydrograph line, so which is denoted as AC. So, and an arbitrary point is roughly located at time n is equal to 0.84 into A to the power 0.2 days, where n represents the number of days after the peak of hydrograph. So where A represents the drainage area in a kilometer square. So if you see the figure here, you can see here, see this particular point is the point of rise. So the first method is, so you have to draw a straight line from the point of rise to an arbitrary point, which is C. Okay, so where this arbitrary point is selected to be occurring at n number of days from the peak flow. So this is the peak flow. So from the peak flow, so this arbitrary point C is selected to be at n number of days, where n is equal to 0.82 into A to the power 0.2. So that is where A is the basin area. So this is the first method of base flow separation. So this line AC represents the base flow separation line. So similarly, you have the second method. The second method is the recession curve existing before the point of rise. Okay, the recession curve which is existing before the point of rise is extended to a point under the peak of hydrograph, so which is AB. Okay, so from that point, a straight line is drawn to a point of end of direct runoff. Okay, so the line ABC represents the base base flow separation line. So if you see the figure here in this particular part, so the line ABC, see this is the ABC line, so which represents the second method of base flow separation. So first what you have to do is you have to draw a line AB. So from the point of rise to a point which joins the peak flow. You can see this is the peak flow. So from the a point of rise, so you have to draw a line AB which represents the AB. So where you can see here, so the recession curve existing before the point of rise. So you can see here, so before the point of rise means, so you can see B is before the point of before the point of rise, that is A. So B is before A. So from A you have to draw a line AB, and after that, so you have to join this the point which joins the peak flow, so to join an arbitrary point, that is C. So where this ABC line represents the base flow separation line from the second method. So the last method, the third method is this base flow curve on the recession side of the hydrograph is extrapolated backward, okay, to the point of inflection on the recession limb, and then it is connected to a point of rise by a smooth curve. So you can see here this third method, so first what you have to do, so you have to extrapolate backward. You can see here this point E, from the point E, so we are extrapolating the curve backward, so that it joins the point of inflection. You can see this is the point of inflection at the D. So the curve which is extrapolated backward is meeting a point of inflection at D. From that particular point you have to draw a smooth curve, so to the point of rise, so where the line ADE represents the third method of base flow separation. So these are the three methods which are used to separate a base flow from the given hydrograph or from the total runoff value. Thank you all. Let us see the next concept in the next class.